Alright, let's see. Today we are looking at that worksheet I gave you on Friday to finish off the week. It was an acceleration time graph, and from this graph I wanted you to create the other two. I wanted you to create a velocity time graph and a position time graph. And of course, to do that I got to tell you how fast it was going and where it started. Okay. I've taken the liberty to go ahead and label and scale my axes already. Here's my velocity time graph. It goes from -4 to 4. Here's my position time graph. It goes from 0 up to 10. Okay, so let's just go ahead and get started. It says assume the object started at rest. So I know right away my first point is 0. And since my acceleration is 0 for that first second, that tells me this object does not change its velocity, so it remains at 0 meters per second for that entire time interval. My next time interval, from 1 to 2 seconds, there's two ways I can do this. Okay, I have a positive acceleration, a positive constant acceleration of 2 meters per second every second. That means after 1 second I need to be going 2 meters per second faster. That is, the slope of my velocity time graph is 2. The other way I can look at that is I can say, well, the area of this rectangle is 1 times 2, which is 2, and that means my velocity needs to get different by 2 meters per second in 1 second. Either way, I end up right here. My next time interval, it says right here that there is no acceleration. It doesn't say the object stops, doesn't say the object reverses direction, it says there is no acceleration. And that means it stays at whatever speed it's at. So it stays up here at 2 meters per second. Then my next time interval I've got is this one. Okay, and it shows me a negative acceleration, -1 meter per second per second. That means every second my speed needs to decrease, my velocity needs to decrease by 1 meter per second. So if I'm up at 2, 1 second later I'll be going at 1, then 0, then -1, right? And this should be a straight line, and it's like a straight line. Alright, so it does something like that. The other way you can look at that is you can say, alright, the area here is 3, but it's -3 because it's below the axis, so I should get slower or change my -3 meters per second. So I did. Okay, next time interval here says don't change, be at a constant velocity because I have no acceleration. So wherever it's at, it's going to stay there for the next 2 seconds. Okay. And then my final time interval is right here. Got a +1, so my slope is +1. Yuck, that was a horrible one. +1 meters per second for that final time. Okay, and so every second I get 1 meter per second faster. The other way is area is 2, so and it's +2. So I need to have a positive change in velocity of 2 meters per second. And I did. Okay. So hopefully that's fairly straightforward, right? You can either look at areas or you can say, well, these are just graphing slopes and all my slopes are constant. Let you in on a little secret. All our acceleration time graphs will be horizontal lines, and all our velocity time graphs will either be horizontal or sloped. There will not be any curved lines in the velocity time graph and no slopes in acceleration. That's because we're only going to deal with constant accelerations. Okay. This last part is just a little bit tricky, but it isn't bad. So we'll start with our first interval and pay attention to this right here. 2 meters from the origin, so I know I started right here, +2. And since my velocity is 0, my position doesn't change, right? Velocity is rate of change of position. So for the first second, I stay right there. Now, this next second's a little bit trickier. I start moving, and I got to get going pretty fast. But I need to know a change in position. That comes from area, so I'm going to find the area of this section of my graph, okay, half base times height because it's a triangle, so 2 times 1 is 2 times a half is 1. That means in 1 second I need to go 1 meter, so I'm going to go from 2 up to 3, and I got to go faster while I'm doing that, so that's going to be a curved line. Okay. The next second Again, there's a couple ways you can look at doing this. You can find the area, you can tell it's graphing slope, whatever you'd like to do. This says I've got a slope of positive 2 for 1 second. So I'm going to go up 2 over 1, draw that line. Okay. The other thing is I can say the area is 2, so that means my position needs to change by positive 2 in the next second. Well, 1 meter, 2 meters, there it is. Okay. Got to be a little bit careful on this next time interval. Okay, right here it's still moving away because it's still a positive velocity, but it's getting slower. Now the area here is half base times height. 2 times 2 is 4, divided by 2 is 2, so it's got to go 2 meters in 2 seconds. So it's going to end up over here. Okay, 2 meters in 2 seconds. But it's getting slower, which means my line has got to curve concave down. Okay. Next second, I'm going to switch colors because this is a different time interval here. So let's go back. Let's go with black. Okay. So this time interval is this 1 second. Well, it switched direction, so now it's coming back towards the detector, and it went half a meter, right? 1 times 1 is 1, divided by 2 is half. So it went half a meter back towards the detector in this time interval, and it's getting faster, so it's got to curve down. Then it stays at negative 1 meter per second for 2 seconds. So I'm going to go down 1 over 1, down 1 over 1. Or I can say the area under this curve is 1, 2. So I gotta change by 2 meters in a negative direction in these 2 seconds. So we'll connect up the dots, and there we go. And then this yellow line, okay, says, well, move towards the detector still, but get slower while you're doing it, right? Because it's headed back towards 0. And again, that's a half. So over the next second, I've got to get half a meter closer, and it's got to slow down almost to stop. Okay, and then my last time interval is this one, and I'm going to go with purple again. Okay, and I've got to move away again, another half meter, and speed up while I'm doing it. So it should look something like that. Okay? It's a little bit of a complex graph, but it isn't bad. If you just keep track of where your velocities are, where your positions are, and what the graphs mean. Okay, drawing your curves, it doesn't have to be perfect as far as your curves go, but your final and initial position, you should be able to do things like that. Okay, so that's what these next questions are about, and we'll answer those and be done. So number 1, what is the object's displacement after 10 seconds? Well, if we come over to our graph and look, here it is. It's up here at 4.5 meters. So I know my final position is 4.5. I know my initial position was 2. So xi equals 2. 4 minus 2.5 is 1.5. That's really bad looking, but I'll go with it. 1.5 meters. Okay. What was the velocity of the object at 6 seconds? Okay. I want to know a velocity at a time. I'm going to come to a velocity time graph. At 6 seconds, it was negative 1 meters per second. Okay, it was moving towards the origin. I could get that right off my position time graph too if I come over to 6 seconds. Okay, I've just started this slope of negative 1. And number 3, sketch the velocity time graph if the initial velocity was negative 2 meters per second on the velocity graph above. Does this change a whole lot? The answer is no, not really, right? Because the starting position is telling me where to start my graph, but acceleration graphs slopes. It doesn't graph velocities. So I could come over here and I could say, all right, negative 2 is where I start. I still have no acceleration for the first second. Then I still need to increase and get more positive. Then I need to stay constant. Then I need to get more negative, 1 meter per second. Then I need to stay there, not change. And then I need to go ahead and come up. I feel like I went one interval too far. Maybe not. 1 meter per second for 2 seconds, and I'll end right here. And it looks exactly the same is just shifted down. Okay. Now would that change your position time graph? Oh, absolutely, that would change your position time graph. This new line over here is all negative, which means this whole time that this object is moving, it was moving towards the detector. Okay, we would have to completely redraw this, but we don't have to do that. Okay, all right. Let me know if you guys have questions.